Hello everyone, welcome to Module 8 of our Software Design and Development course. We have learned to design, build, test, and integrate software. With even flawlessly tested code delivers very well if it cannot be reliably deployed to users, sell under demand, or monitored in production. Today, we bridge the gap between deployment and operation. We will cover DevOps culture, CI and CD pipeline, Docker container, Kubernetes orchestration, cloud platforms, performance tuning, and production monitoring. This module transforms you from a developer who writes code into an engineer who ships and maintains production-grade systems. In today's module, we will cover the following: core DevOps cultural principles and CI/CD pipelines, containerization with Docker and orchestration with Kubernetes, major cloud platforms such as AWS, Azure, Basel, and Heroku, continuous integration and continuous deployment automation, performance tuning, caching, and scalability, production monitoring, logging and tracing, evaluating, verify software hosters, and finally, security, efficiency, and infrastructure as code work. Deployment is not a one-time event. It is a continuous automated process. Modules 1 through 7 give you design, back-end, front-end, and testing skills. But professional software engineering requires one more thing: the ability to ship. Whether you are launching an LMS for thousands of concurrent students, scaling an ERP for global supply chain, or deploying real-time dashboards, your ability to integrate deployment with cloud infrastructure determines system resilience, cost efficiency, and user satisfaction. This module introduces DevOps, a cultural and technical movement that shortens the development lifecycle through collaboration, automation, and continuous feedback. Mastering deployment and cloud integration is what separates coders from professional engineers. DevOps breaks down silos between development, QA, and operation. The core principles are culture and collaboration for shared responsibility, automation for scripting repetitive tasks, infrastructure as code for managing servers via version control compute, DevSecOps embedding security throughout the pipeline, CI/CD pipeline flow from continuous integration is for frequent mergers, trigger automated tests to catch integration but fail. While in continuous delivery, every passing change is automatically prepared or released to production. This pipeline is the heartbeat of modern software development. Containers solve the classic problem. It works on my machine. Core concepts are hidden, read-only templates containing apps and dependencies. Containers running isolated instances of containers, while data files defining how to be used. Example Docker file for Node.js platform. For multi-functional app and database, we use Docker control. Containers standardize runtime environment from development to production. Docker runs containers. Kubernetes manages them at scale, automating deployment, scaling, and operation. Key concepts are pod, smallest deployable unit, one or more containers. Deployment manages replica, set, and rolling updates. Service, stable network endpoint routing traffic support, config maps or secret, externalize configuration sensitive data. Example Kubernetes deployment for YAML. With Kubernetes, you can scale from one replica to hundreds with a single config. Cloud platforms provide infrastructure on demand. Major providers are AWS, which is most mature, expensive services. Azure, which is enterprise friendly and has Microsoft integration. Basel optimized for front-end and Next.js in the app. Heroku is simple, beginner-friendly PaaS. Deployment strategies are rolling updates, gradual replacement of old versions, blue-green to identical environment with strategy instantly. Finally, roll out to small user subset fast. Feature flags Google features without the deploy. Choose strategy based on risk tolerance and user end. Let's see a real CI/CD pipeline using GitHub Action. Every commit here remain triggers automated testing, and if all passes, automatic deployment. Secrets like API tokens are stored securely in GitHub secret. Good deployment isn't enough. You must handle growth without degradation. The scaling approaches are vertical scaling, which is bigger, which has bigger server, more CPU, and horizontal scaling, more servers than distributed load. Performance techniques such as caching with rate reduce dramatically reduces database load. CDN distribution is a static asset start from edge location. Database indexing and query optimization prevents N plus one query. Async processing of less heavy task speed in rapid MP and SP. Optimized system scale, unoptimized system fail under pressure. You can't fix what you can't see. Observability has three pillars. Metrics, which is the quantitative data in CPU, memory, request rate, and error rate. Traces, request flow across distributed services. Maintenance practices are automated daily backup with point-in-time recovery, regular OS and dependency security patching, health checks for load balances, disaster recovery tools consume run-book documentation. Proactive monitoring prevents outage before they affect users. Not all hosting providers are equal. For production systems, please verify hosters. Evaluation criteria are uptime, SLA, SOC, and ISO compliance and audit plan. Automated scaling, manage database backup policies, transport pricing and cost monitoring tools. Categories include cloud giants such as AWS, Azure, GCP, platforms, PaaS, Heroku, Render, Slido, Auto, front-end focus, Basel, and Metrical. Never deploy critical applications on undated infrastructure. Professional deployment discipline are for security and efficiency. For security, always use bold and secret managers. Never commit to a spam file. Enforce least privilege role, scan dependencies, and enforce HTTP plus TLS 1.3 FPS header. For efficiency, define infrastructure via Terraform. Implement feature flags for safe incremental rollout. Right-size instances and implement auto-scaling policies. Document deployment, runbooks, and rollback procedures. Do's and don'ts in DevOps and deployment. For the do's, automate everything. Use test deployment and rollback. Use staging environment that mirror production. Implement structured logging and alter alerting thresholds. Monitor cloud costs. Do not add core credentials or export secrets in CI/CD log. Do not deploy to production without automated testing. Do not ignore database connection fully, and do not skip backups or self-test disaster recovery. Do not manually deploy during peak hours without rollback strategy. In conclusion, today we cover the complete deployment and DevOps landscape, such as DevOps culture and CI/CD fundamentals, containerization with Docker and orchestration with Kubernetes, cloud platforms and deployment strategies, automated CI/CD pipelines with GitHub Actions, performance tuning and scalability techniques, monitor logging and observability. This knowledge prepares you for modules 9 and 10, building real-world enterprise applications like accounting systems, ERPs, and LMS platforms, plus professional career practices, portfolio deployment, action projects. See you in the next module.